Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. In this episode, we're joined by Pat Woowong, Principal Engineer in the Applied Machine Intelligence Group at the Home Depot. We discuss a project that Pat recently presented at the Google Cloud Next conference, which used machine learning to predict shelf-out scenarios within stores. We dig into the motivation for this system and how the team went about building it, including what types of models ended up working best, how they collected their data, their use of Kubernetes to support future growth in the platform, and much more. Enjoy. All right, everyone. I am on the line with Pat Woowong. Pat is a principal engineer in the Applied Machine Intelligence Group at the Home Depot. Pat, welcome to This Week in Machine Learning and AI.
Thank you for having me, Sam. It's a pleasure being here.
Pat, so why don't we get started by having you tell us a little bit about the Applied Machine Intelligence Group and what your focus is there?
Sure, of course. So the Applied Machine Intelligence Group at Home Depot it's kind of like a newly formed team. We've been around for about a year with the current team members that are on the team. And our primary focus is to operationalize machine learning. So what that means is I'm sure like all the people that are listening to this probably know what that means, but for those of you that don't, it's basically taking machine learning models that don't just generate reporting type things. It's things that interact with the real world, things that you can actually have an effect on in real life. So and it's taking stuff from conceptualization all the way to production. So we do everything from the discovery work to building the models, data pipelining, even app development, and putting that into production for business teams.
And do you have a established platform for productionalizing these types of projects, or do you tend to build out infrastructure on a case-by-case basis, depending on what a specific application needs?
That's a good question. So typically, I think a lot of productionalization of ML models follows the same kind of pattern. It's data pipelining, step one, and then feeding the pipeline or the tables that you have or whatever data you have into the model, step two. And then three, doing something with that information afterwards. And then potentially feeding that information back into the model for it to learn off of if you have like an active learning model or something like that. And what we did with this very first project that we presented at Google, we basically built out a bunch of infrastructure that didn't exist. We built it all in Google Cloud. So for those of you that don't know about Home Depot's transition to Google Cloud, we recently have begun I wouldn't say recently, maybe like 2 years ago, we started this massive journey to move all of our enterprise data warehousing into Google Cloud. And it has been a huge success for us as a company because we're now able to do all of these things and experimentations in the cloud without having to buy more servers to put them in the data center, stand up hardware. We can just request request resources on demand, and we can try things out without having to spend a lot of man hours to get that infrastructure stood up in our own data center.
So the specific project that you presented on was one focused on minimizing shelf outs at Home Depot stores. Can you talk about the context and origin of that particular project?
Yeah, it's really interesting how this project came about. Actually, one of the data scientists that's on my team, he was part of the supply chain organization within Home Depot, and he had this idea to, and his name is Sashi Gandavarapu, and he had this idea to use signals from within the store to kind of predict whether stuff would be on the shelf. So the reason it was kind of like a really important idea is that within any type of retail space, unless you have cameras or sensors or some kind of thing within the store to track products, once it enters the store, you almost have no idea where it is until it leaves the store either through the register or shrink or something like that. So he had this idea to use data from the sales or there. Well, we can get into like the features in a second, but essentially using data to drive the shelf out prediction. So what a shelf out is something is in the store but not on the shelf, and that's not the same thing as it being out of stock. Which is obviously, if it's out of stock, then our supply chain will react to the out of stock levels, and it'll be retriggered through the supply chain, and it'll obviously come back to the store for someone to put back on the shelf. But this is for stuff that gets either someone picks it up off the shelf and you don't know where it goes. Like maybe they try to buy it, but they were like, okay, well, I don't want this anymore. And they get to the checkout line and they don't want it anymore. Or maybe someone takes the item, or steals it, or
maybe it's just sitting on top of the shelves in those racks. Yeah. I mean, we've probably all had this experience where we go online. It says there are 20 in the store. You go to the shelf and there is just a big hole, and you got to find someone, and they climb up on the big ladder and sort through those boxes.
Yeah, and I actually mentioned that in the talk on the Google talk is about the Home Depot is kind of like a working warehouse, so there's no back room. So if it says there's 4 in the store, they're probably in the store somewhere, but we probably don't know where they are. And it usually takes quite a long time. If it's not on the shelf and it's not directly in the overhead right above that item, then it'll take hours to find it.
And one of the things that I appreciated about the presentation you did is that the way you approached this project is that you didn't just assume that this would be a good idea. You actually manually brute forced it, as you said, by having people manually stock the shelves, and then you measured the revenue lift from actually having the products on the shelves.
That was something that I think Home Depot is very, that we do quite often with a lot of these tests. So before we're allowed to go past like a POC stage, or even before we go to POC stage, we have to determine the ROI for the project that we're about to do to convince people to give us money to do the project. So in order to do that, we said, okay, well, if we had a system that could continuously keep stuff in stock, or in stock and on the shelf, what would that look like, and how much money would that actually generate? So you add labor into the store. Obviously, it's not scalable to the entire company to add labor that just does pack downs the entire time. When pack down is like moving stuff into the shelves, but it essentially simulates what our project ended up doing. And from that, we were able to determine the sales lift from doing something like that, and the ROI for developing this kind of technology.
In fact, that you saw that just by increasing shelf availability by a single %, you were able to justify kind of continuing on with this project. How did you approach the next step, which was kind of the modeling step?
Yeah, so what we did was we built some ETL pipelines to pull data in from the various different sources that we were going to use: supply chain, sales, space planning. There's so many different data sources. I can't even list all of them. I think some of the features that we generated were in the deck somewhere. But anyway, so can you give us some examples of those?
Sure,
of course. So this is an interesting one. So Sashi actually likes using this example, and it's a very good example of a really interesting feature. Is when something comes into receiving in Home Depot, we sometimes there's this notion of something called shelf capacity, and shelf capacity is how many things you can put on the shelf at one given time. Sometimes what ends up happening is you receive a pack of something, and the ratio of that pack to how many things you can actually put on the shelf is not an even number. And what I mean by that is like there's a remainder, obviously. So let's say you put 7 in the pack and then 4 on the shelf. So you end up with 3 back in the overhead. And to an associate, they're going to say, okay, well, is there more things to be put back on the shelf, or is that shelf actually out of stock? And that thing for that trigger for someone to go look for those other three things doesn't happen all the time. So sometimes things get lost in the overhead until someone actually goes and looks and finds it and says, oh, there's three of these things. I better go put it on. But when people change shifts, they don't know exactly where the other person who did the stocking before put that thing. So it gets lost. And that leads to shelf outs. So that ratio of pack size to shelf capacity is an interesting feature that comes from different things, right? So it comes from the planogrammed size of the actual thing that you're trying to put on there. So how much shelf capacity is, and then also when was the last time it was received from the pack size from supply chain. And that can vary actually between stores. So sometimes some stores get more in a single pack size, and sometimes, yeah. So that's like an interesting thing. Obviously sales is a huge indicator of a shelf out. The forecast of what we expect to sell, what its price was, the on hands that we have. So like, let's say we had 3 of them yesterday, and then 4 of them the day before, and then 8 of them the day before, 3 days before. So like that slope of something decreasing over time is also another thing that we use as a feature.
Interesting. And you mentioned that the data that ultimately comes to feed the model came from a bunch of different sources. Is there a way to characterize the number of sources or the level of effort in just building out that data pipeline?
Yeah, it was a pretty monumental effort, I think, because it was a very cross-functional effort to get all of this information. And Home Depot's such a big company, and there's different teams that are responsible for different data sources. So getting all of the teams to help with we use a lot of them as like advisory roles as well, because we weren't able to think of every single feature that went into this model. They came up with some ideas for us. So we met with a lot of these teams over the course of several months, and they kind of helped build out this feature set. Some of them including like obviously space planning, finance, supply chain, inventory planning and replenishment, store operations. There's a lot.
You kind of talked about this data pipeline and all this data that you need to receive from different places. How much of that came before the modeling process, like in the exploratory phase, and how much of that effort was, when you're trying to productionalize? Like, I'm imagining in the modeling phase you're doing samples, but even those samples might have had to have been fairly large. Like, how did you approach that?
Yeah, so some of the features some of the data sources that we used weren't even in the cloud when we started building this model. So we actually had to develop the ETL pipelines that would put this data into the cloud from the operational databases. That took a little while. There were several of those that we had to do. So when we were gathering all of this data, it took, I would say, like 6 months to get everything in a stable state before we could actually. I guess the modeling happened simultaneously, but as we were trying to so we had samples of this as we were going along, like you said, and we were able to build these models off of like old data. But in order to get it to a state where we could run the training process on a weekly basis took quite a long time. We're trying to remember like all the details of all the things that we did, and there's just so many of them. And we had help along the way, right? It wasn't just our team. Like there were other teams, cross-functional teams that were telling us where stuff was, because it was very difficult to find databases. You can imagine like how many databases Home Depot has for every team that exists there. And various different teams within Home Depot are in different stages of their cloud journey too. So sometimes we'd work with some teams that would know how Google Cloud worked and the lingo and all of the different types of technologies that are available in there. And then some had no idea because they hadn't really started that journey yet. So it was definitely an interesting challenge doing that.
What did you end up with in terms of a model? Either the details or
Sure.
Some sense of the complexity there.
Yeah, that model was actually pretty simple. So the original model that we built was a random forest model. I think we used scikit for the initial one, and then we switched to XGBoost, so gradient boosted trees. Mm-hmm. and it actually performed really, really well for our purposes. And we felt like it was good enough, and we didn't need to explore anything any further than that. But we do. So when we also engaged Google Professional Services about halfway through our journey, and they helped us build a TensorFlow model using Dataflow or Apache Beam, and it ended up. I think the performance was about the same as our XGBoost model. So we went with a more simple model just for trying to get it out there. So we were kind of like on the clock to deliver some results. So we wanted to show our business partners like, hey, this thing is going to work. And there was a lot of, I don't want to say skepticism, but there was a lot of like, I would say, you kind of like have to convince people how ML is going to add value. And we really wanted to show that it was going to add value because we saw the results through our paper validations, right? So after the initial model was built, went to the stores and validated, did some like paper validations. We're like, okay, wow, this is actually going to work. So let's get this to a production state as fast as we possibly can. And as fast as we possibly could wasn't really, I don't think it was fast enough. We were kind of, we had a lot of technical challenges to get it there. But obviously, this was the first one that all of us did together. So we learned a lot along the way.
Well, I want to dive into some of those technical challenges further. But before we do that, I'm curious, what would you say accounted for most of the skepticism on the part of your business partners? You showed them that if you increased shelf availability, you can generate a ton of incremental revenue. So I imagine they bought into that. Was it specifically they didn't think you'd be able to predict shelf outs given the data that you had available in the stores?
I think there's just kind of like a misconception about what machine learning does and how it can add value. Because I think a lot of people currently think it's like one of those hype technologies, right? Like everybody thinks that that they need it for whatever problem. And I don't think like it was their focus at the time to adopt this into their stack yet. Because, we were a new team. And like the way that our team is positioned within the company isn't that we're not like part of the team that we're building this for. So in essence, we're kind of like consultants within Home Depot, if you will. Mm-hmm. And we kind of like build these things out. I guess we were more seen of like as a POC team versus like getting something all the way somewhere or developing something all the way to its productionalized state, even though we could. And we were kind of like trying to prove our worth, if you know what I mean.
Sure. So you started building out these data pipelines in parallel with the modeling step. At some point in time, you had the data pipelines and the models in place. What was next? And if I skip something in kind of setting that up, definitely.
No. That's perfect. So yeah, after we had the model, we knew it was producing valid results, actionable results. We had to build some service layers to be able to send the model predictions to the stores. So that took a little bit of time. So we ended up integrating with an existing application that's already in the Home Depot that associates are they're familiar with using. And this was at the SKU level that we wanted to send predictions at. So it ended up being like a perfect app for us to use. We used this app and we made like one slight modification, which enabled us to solicit feedback from the users. The thing that we added was a shelf out yes or no on the screen where they're actually going to check these items. So they can see if we can see if the things that we're sending are actually accurate versus just blindly sending them out. So then that was like the next biggest thing. And that kind of, I think we should have probably done that a little bit sooner. That development step really took a lot of time, and it was basically like we were working on that the entire time before being able to get any further. So it was kind of like a roadblock for us at the time.
And so specifically, this was hooking into the existing app, and I think it was an app that is on these little mobile devices that the store associates have.
Right. Yeah.
And are you hooking into an existing notification process that is
Right.
targeted to specific associates, or does it go into a queue? But it's basically like a pick list or checklist of items that you need to check on their stock out status and or restock if necessary. Oh,
Yes,
not stock, but shelf out.
Yeah, that's exactly what it is. So
Okay.
that application it's called Smart List, and what it was traditionally used for was to have associates go and check the stock levels of things that we thought were not at the right levels. So we were like, okay, well, this is like the perfect app to be able to stick this into, because instead of them having to go and check the stock levels, we can check if they're on the shelf too. So we added this button to allow that to happen. And now we're getting data from the stores that we're live in about the stock levels and if they're shelved out or not when they go and check them.
For the purposes of the development with this app, you weren't asking them to count the number of items on the shelf, like a shelf inventory. It was just on the shelf or not.
No, actually, they still do that. So we tried to make it as minimal in terms of having to retrain people as possible. So we didn't want to introduce like a new workflow to them at the time. We kept the app exactly the same pretty much, and we didn't do anything except for adding this one button that they had to do during their normal inventory checking process. So it made it so that it's kind of like more intuitive, so no one really had to know what was going on behind the scenes. Like to them, the tasks were identical. No one really knows like if the tasks are coming from the original task generation system or from us.
And so if I could ask the rude / ignorant question, when you look at the picture of this button, it's like on shelf, yes, no. But yet you said it was really complicated and took a long time. Where is the hidden complexity in that button that seems so easy?
It's yeah. Without saying like anything too bad, it's like the framework that was used on it. I wasn't very familiar with it, so I had to learn how the deployment process was set up. So this is where all the complexity came in. I had to learn how all of that was set up, how their deployments work, how to deploy their code to the stores, which takes a long time. So Home Depot, obviously, we're very we don't like deploying potentially breaking changes to the store environment. So there's a lot of checks in place to make sure that what you're actually deploying is not going to break anything. And all of those processes that are there are the things that make it complicated. So the actual app, changing the app actually wasn't that hard once I was able to figure out what to change, and then building the services that were on-prem that hooked into that. So Home Depot stores are kind of like they have their own kind of data centers inside of them, and they don't feed off of a centralized location per se. So there's a really, really long, complicated deployment process. So that's where a lot of the complexity comes in.
Makes sense. So you've got this capability now deployed out into the stores via this app. How do you tie that all together with the model?
Perfect. So the model runs every day at 6 o'clock in the morning, the predictions part, and we generate all of the tasks that are supposed to get sent to the store for that day. And we're not sending. I think we send them over like a certain confidence threshold. So like I think if we think it's I don't remember exactly the percentage that it's set at, but if they're over a certain confidence level, we send the tasks to the stores, and we only do, I think we send maybe like 150 or something like that per day to each store to have them go fix, which isn't really that much in terms of how many there are. So there's like 33,000 SKUs in any particular Home Depot store, but we're only really trying to fix about 150 of them per day, which ends up adding over time. So hopefully like those 150 you fix in one day will be it'll kind of like have a cascading effect over time.
And are you sorting by confidence, or are you sorting by profitability or some business metric?
So we haven't actually started doing the profitability, the business metrics yet. So we exclude some of them. Obviously, there's departments like lumber where it's very unlikely that even if there was a shelf out that you could fix it, because if the lumber is not there, then you can't get any more. And yeah. And there's other categories that are like that. So as we were pushing this out in our pilot stage, we found a lot of interesting things that we didn't really know about the store landscape and the overall shelf out rate of individual departments. So obviously, like your high selling things like your power tools and stuff, there's a lot of people buying those all the time, but stuff like the blind section wasn't as so like we were sending shelf out predictions to them that weren't accurate in the blind section, so we ended up just not sending those ones at all either. There's a couple other categories that were like that. Those ones stand out the most, but it was interesting seeing that data come back that obviously like we didn't know before that those things would happen. Another interesting thing that happened as we were deploying this out was because we had that 6 o'clock. I guess our SLA for sending these things out is 8 o'clock in the morning, but we start running the pipeline at 6, with up to 8 o'clock being the last time that these tasks can go out. The reason being is we want to make sure that the tasks that are going out to the stores have not been affected by people doing things in the stores, because the data that we have right now is not coming in an hourly cadence. So we can't really do predictions on an hourly level yet because of our data sources. So we need to make sure that when we're sending these tasks out to the stores that the tasks get to the phone before anyone has done anything to change the store. Mm-hmm. So that's why we set our SLA to 8 o'clock in the morning. And if it doesn't meet that SLA, then we don't send anything out because it would affect our accuracy.
It sounds like we've kind of closed the loop on this process and how the predictions are being made. At least you run your pipeline daily. Are you also doing periodic retrains?
Yes, we are. So we're retraining weekly at the moment. So that's actually another interesting that we found is that the model would become stale after like 2 weeks. Our accuracy started dropping, and we were like, okay, well, does that mean that it's not good anymore, or what was going on? This is when we were only live in one store and we hadn't set up automatic retraining yet. So we retrained the model off of the latest data that we were getting back from the shelf out data, and we saw the accuracy jump back up, and we were like, okay, well, there's got to be some kind of thing that something that's going on that causes that to happen. And I think it's a combination of the things that are being sold in the store are very seasonal. So Home Depot, obviously, and I guess a lot of other retailers, or maybe Home Depot specifically, has a lot of seasonality. So like things that are being sold in the spring usually don't get sold in the summer, especially things that don't get sold in the winter don't get sold in the summer, like snow blowers and things like that's a good example. And grills get sold a lot in the summer, but yeah, so like incorporating that last week of data into the training really improved the accuracy of it. And we tried to, we assumed, or maybe not assumed, but we hypothesized that training on a year's worth of data would capture that seasonality, but it didn't. So we still have a little bit of digging to figure out what's going on there, really.
Maybe getting back to the kind of the infrastructure elements of this system on the, starting out with the ETL pipelines, how did you implement those?
So yeah, we did all of the ETL pipelines in BigQuery. It was relatively easy to get all of those data sources in there. I really feel like it wouldn't have been possible to get all of these different cross-functional teams data in an easily consumable way if we hadn't done a cloud migration yet. So that was kind of like a key component or key thing that had to happen for us to be able to do a project like this. And I think I said this when I was at Google or doing the next presentations this is a huge initiative that allowed projects like this to even happen, because we couldn't have even imagined tackling a project like this before without having that amount of data in one place for us to get it. So yeah, the ETL pipelines, they're all done in BigQuery. We feed that into Google Cloud Store, or we extract that into Google Cloud Storage, and then we feed that into our model. Then our model writes something back into BigQuery, and then we have a service that picks those inferences out of BigQuery and pushes them to the phone.
Can you elaborate on this loop BigQuery to storage back to BigQuery?
Sure. So the Home Depot has and this is something that a previous team that I was on built. We have a thing that automates all of our ETL process, our extraction from on-prem to Google Cloud, and we use that same tool to help us automate a lot of our running processes. So our model, it runs on a Kubernetes cluster. So we send the model code off to the cluster to run, but in order to chain all of these things together, we have a bunch of SQL that runs in the beginning, and then SQL being BigQuery SQL. And then after the SQL data prep steps, I think there's probably like 15 data aggregation steps before, maybe even more. There's probably like 20 if you count all of the ingest pieces. So I would say about like 15 to 20 SQL steps, and then after that, the resulting features table is exported to Google Cloud Storage for the model to consume, and then the model reads it all into itself because it's a XGBoost library that we're using, and XGBoost is fed in with Pandas, so we just read it in with Pandas, put it into XGBoost, and then let it do its thing. And then afterwards, the model then writes all of its results back into BigQuery. So that's kind of like the circle of how that works. And then there's a little bit there's some other steps that do the sending of the task, right? So we have to obviously send this out every day at 6 or by 8 a.m. So we have another process that picks all of those tasks up and sends them to the individual store servers. And then obviously whenever the associates come in and they work the tasks, they hit the yes or no button on the app, and then we get our feedback and we can find out how well we're doing. And then that goes into another cycle. Although I will say one caveat, we have not started retraining our model off of the data that's been coming back from SmartList yet. The reason being is that we don't have enough of a sample to be able to do that with yet. So the model or our project is live in around 50 stores at the moment, but it's not a large enough sample size that's like representative of the entire company to be able to build a model off of it yet. So we're waiting until we get past our 50 stage or 50 store current stage, and then once we get to like maybe, I don't know, I think we'll probably start building out that pretty soon, but I'm not really sure at what level we're going to consider putting that back into our new model.
When you talk about that feature, are you thinking about that in the sense of like an active learning where you're dynamically updating your model, or just using that information for additional feature?
I think we're probably going to go with an active learning type of situation where it might update the model as it is. I mean, ultimately what we really want to do is have this work on an hourly basis so it can react very, very quickly to these types of situations versus having to wait an entire day. I think we're pretty far away from being able to do that, but I think that's the dream, is being able to get it to that level. Mm-hmm. And I think active learning would definitely be the thing that we would want to go to.
So you mentioned you've got a Kubernetes cluster. Is that where the model's running?
Yeah.
You've got containerized scikit-learn or Python somewhere that is, you're kicking off these containers and they're just as part of their launch, they're pulling data and running the model?
Yep, that's correct.
How many instances or pods or containers? What's the best way to measure that, the kind of scale of that piece of it?
It's not really that big. So I think we run on. I think we're using like CPU training right now, actually, which is it actually serves our purposes for now because we haven't had to change anything. But it's like I think it's like 15 vCPUs and 50 gigabytes of RAM per pod. And we have I mean, the nice thing about Kubernetes, obviously, is like when you're not using it, it scales down to zero. So
Right.
So whenever we launch jobs, I guess that's for like the training part of it. We use like 50 gigabytes of RAM and 15 CPUs. The data size is around 66 million SKUs. So you just take the number of SKUs per store times the number of stores that we have. So it's like around 66 million per store. So that's around the data volume that we're doing. It's not anything like super huge in terms of what you would use. I take that back. Sorry. That's like the maximum amount that we use for in our inference pipeline. So that's like the biggest that it'll ever get, really, for our inference pipeline. For our training data set, before any of the data preparation happens, our sales table is massive. Every transaction that's happened at Home Depot for the past 7 years. So it's pretty big. It's like several terabytes. The supply chain data is crazier. Though that's like, you can imagine like a supply chain, right? So it's every time something gets touched in a supply chain has a row in a table. And it has all of its history maintained too. So that one's even bigger. But I think the training set that we end up with is trying to think. I think it's definitely less than 50 gigabytes. It's not very big.
Okay. And so these 15 vCPUs with Kubernetes, how many actual nodes is that? Is that 15, or are you using the core?
It's just a single node with that turned up for now.
Single node, single worker, or multiple workers?
Single node, single worker for now.
Got it. And so you've got this single node, single worker setup. And even in that kind of scenario, you're still taking on the overhead of Kubernetes because of what? Just kind of ease of deploy and replicating containers and stuff like that?
Yeah, that's a good question. So initially when we were building this out, we wanted to have something where we could run other projects in. So we didn't want to be limited by, we wanted to be able to submit jobs to this cluster for when we wanted to start other projects, essentially being able to do this thing and take on more projects, take on more work, and do more types of exploratory work throughout the company. So that was our intent of building this thing out the way that we did.
And it sounds like you're running it on GCE as opposed to GKE?
We're running on a GKE.
Oh, okay.
Yeah.
I guess I was thinking that you don't think about the vCPUs in GKE.
Yeah. I mean, yeah, you can set the node size or in the node pool settings on GKE I guess you can. The way that we have our setup is we have one cluster that does our training and predictions. So they're different node pools, and each node pool has different size of nodes that it can pull from. And then when we request the CPU from the job configuration, like the training job, obviously it has its affinity set to the training node pool, and then vice versa for the predict.
If I remember correctly, at Next, Google announced a bunch of extensions to BigQuery. BigQuery ML, I think, was what they called the machine learning extension. Is that something that you see as playing a role in this type of system? Have you looked at that at all?
I have, yeah. I think BigQuery ML has it's actually a really, really cool tool. So I've played with it a little bit, not a lot, but I think from trying to do some discovery work and seeing what kinds of things are there, it's an amazing tool because you don't have to build anything to try it out. It's literally just using whatever the semantics that they put in there to be able to run a model on top of it. And I'm sure they're coming out with tons of other models that you can run inside of it. And just based off that alone, it'd definitely be worth us trying to see how well it does compared to our current system. Mm-hmm. We just haven't had time to do it yet.
So maybe to kind of wrap things up, where do you see this progressing from here, both in terms of the shelf out project? We've talked a little bit about future directions there, but also additional projects kind of in this vein at Home Depot.
Yeah, so that's something that our team is kind of like trying to do is kind of, democratized ML throughout the company, make it easy for other teams to do stuff like this. With shelf out specifically, we obviously want to see it deployed to all of the stores, which we're pretty sure is going to happen eventually. We're not sure when, but it'll happen. And then also implementing the active learning piece. So using the data that we're getting back from the first phone, from SmartList to be able to do our next wave of training. And I think I didn't mention this earlier, but if you haven't seen the presentation, there's a part about where we gather training data. So at the moment, the training data that we're gathering is coming from another initiative in Home Depot that this team called the Met team is actually scanning outs within a store. They're not doing it across the entire company, but they're doing it across a subset of them. And that's where we're building our training data off of right now. So we want to switch the training data to use the data from SmartList versus using that. And obviously it's like additional labor that's in the stores and whatnot. So ultimately it would be better if you didn't have to do that, because all they're doing is scanning stuff that's not on the shelf. It's kind of boring. So another thing that we want to see happen, I guess like a lot of the infrastructure that we built out again is for taking on new projects. So hopefully there will be some other interesting things that we get that are coming down the pipe. And we're really looking forward to all the other teams that we're going to get to work with in the coming years.
A quick question on this platform idea. It's clear how in the case of the training framework, building it on Kubernetes, you're building a little bit ahead of the requirement for this specific project so that you can easily have infrastructure for future projects. Does that same principle apply on the data pipeline side? Are there specific abstractions that you built to or generalized tools that you built out that you are looking to being able to replicate across different projects?
So we have we have a Beam pipeline that we're not currently using that could be used for the streaming use case. So like if data eventually gets streamed in, we would adopt like a data flow or Apache Beam type of model for ingesting that data. That's a component that we're not currently using that we could reuse later. Another thing is that we have people don't really think about running, I guess you could say, production type workloads for feeding applications off of an analytics type of database. So people don't really think of BigQuery or any type of like enterprise data warehouse as a database that they would use to feed an app. So a lot of the data sources, they come from other teams, yada, 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 and they come at different times. So we built a system to wait for all of these different jobs to finish, and for tables to update properly so that as soon as everything is completely done, our job kicks off automatically. So those kinds of tooling things that we built are definitely going to be useful for us in the future.
Kind of like a dependency checker for data resources.
Yeah, exactly. That's pretty much what it is. And it's actually been working very, very well for us. I mean, our rollout to the 50 stores that we're at. So before we went to Next, we were in 5 stores, and the day that Next started, we rolled out to 50 stores, and we weren't even at the home base to do it. We just hit a button and it worked, sort of.
Awesome.
Yeah. Yeah.
Minimal
I mean, it was
pager.
Yeah, exactly. It was very, very minimal to get it up and running from remotely without all hands on deck kind of thing. So it was nice seeing that happen.
All right, everyone, that's our show for today. For more information on Pat or any of the topics covered in this show, visit twimlai.com/talk/175. If you're a fan of the podcast, please pop open your Apple or Google Podcast app and leave us a 5-star rating and review. Your reviews are a great way to help new listeners find the show. As always, thanks so much for listening, and catch you next time.